My name is Lluc Diaz and I work in the Technology Transfer Office of the European Space Agency. I'm a technology transfer engineer or officer. So today I'm going to talk, I will do a three-level thing. So I will talk about in general what we're doing in the European Space Agency and innovation, what I think is happening in the space industry from a perspective of startups. Then I'm going to talk about what we're doing in the Technology Transfer Office, what are the main activities we do. Take, for example, the amount of passengers that we had in the early 70s and the ones that and the number of passengers that we have in 2015. So back then it was around 300 million people or passengers were flying every year. That was more or less a percentage of 0.05, I think, per year. If you compare it with nowadays, in which the population has doubled, we're talking about 3,000 million of flights a year, which represent almost 1.5 trips per person that is living in this world. So you see that basically what happened in the aeronautics industry is that we basically have democratized the access to a whole industry, but also to the world itself. So now the distances are much more reduced, and that's how really society feels it. The idea is that in space, we can do, or we should do something similar. This is a question I have for all of you, and maybe I will ask my colleagues to turn on the microphone. Do you know how many people in the world is considered to be an astronaut?
We have one answer, 500.
Amazing. So you are completely right. So that represents 10 to the minus 7 in normal planes. That doesn't mean that in 5-10 years we will have obviously the same number of people flying to space, but the idea is that we have to increase this number. Why we want to increase this number? Or why I think that increasing this number has an impact on the space industry? Because it would mean that we have the technologies and we have the investment that are necessary to democratize also the access to space. Democratizing the access to space will lead also to really a conquer of the space. Then I would like to talk about the ESA approach in this context of we need to have continuous presence in space. We need to facilitate the access into space. We have 4 main areas of work: information, inspiration, interaction, and a 4th one that is innovation. And there's where the Technology Transfer Office of ESA is focused. But obviously we also have information, inspiration, and interaction activities. What are the 4 main items that, if we look at in very general, because I'm trying to simplify contextually, obviously the European Space Agency will do science, and science has an impact on society, a great impact on society, both in advancement of the knowledge that we have on our planetary system, so to understand better how we are, or how the Earth and the different processes around us. And there's where the Technology Transfer Office of ESA is playing a key role. And that's a little bit the context for science. Then we have something that is extremely moving to a commercial era. You probably heard about the Sentinel program, well, the Copernicus program and the Sentinels, which is a European Commission and European Space Agency joint project. So basically there's going to be a huge business out of watching the Earth in the normal spectrum, but also in different wavelengths that can provide a lot of information of our planet in climate change, in the agro industry, but also the insurance industry. So there we see that, as I was saying before, it's not just going to be public money, but there's going to be also private money, and then we're going to consolidate much more a space industry that has an impact on society, and then society will realize about why we put money in space. The other thing, obviously, is GNSS, the European GNSS, that is Galileo. It's very important to allow, basically, independence and autonomy from other third parties. Even if we have a good relationship with the States and other countries in space, it's always better not to rely in third-party organizations that are not European to have such an important mechanism to track navigation, but it has a lot of other implications. So new space and new models. I would like to talk about a little bit the vision that we have for how space is moving in general. Obviously, you know about Planet Labs, so how they are creating extremely small satellites, nanosatellites, that can be delivered relatively quick, that can be produced much more quicker than we were producing satellites so far, or that we have been producing satellites so far, and that can be improved also extremely quick. So you fly something, you learn from it, and then you improve it in the next series of satellites, of nanosatellites. Landing or reusability of first stage, maybe at some point second stage of the rockets, as you know, and this is a hot topic. First stage of a rocket is very expensive. If we can reuse it, then there's supposedly a scalability of the business and reduction of costs that can allow and facilitate the access to space. And then the constellations, we're talking here about, for example, the project of OneWeb that is partnering with Airbus. The guys of Airbus and OneWeb, they are working in the low Earth orbit mega constellations, so providing connection to the internet to all the world, and basically focusing in these regions that doesn't have fast internet connection or don't even have. ESA is also, as I was saying, is also supporting certain studies and concepts. And then we have the activities of a SpaceX that landed the Falcon 9 in the Atlantic, I think 3 or 4 times now. So that's a little bit the context of space is changing, and it's changing a little bit more. You know that there was certain limitations on how, if you got or you identify assets in space and you bring it back to the Earth, then you are, or you were kind of framed into public constraints. Who is the owner of, if I bring an asteroid to the Earth, who is the owner of this asteroid? And the Congress of the States changed it to facilitate the growth and the creation of the industry itself, an industry that can be looking at space mining. Probably you heard about deep space industries, planetary resources, and I'm pretty sure that in the next years we will hear more about it. And it's important that we have that in Europe as well, because obviously we need these capabilities. Imagine that you can access, and I'm just guessing now, I'm not talking about reality, but that there is an asteroid that has more gold or another material than we have on Earth. So the amount of money that you can make out of an activity like this is huge. Then, as I was saying, the nanosatellite industry coming obviously from a university point of view, but now it's reaching, or from a research point of view, and it's reaching now more a real business point with companies like Planet Labs. So this is opening a completely new world. Instead of having a big, expensive satellite that can have a swarm of satellites doing the same thing, or a mesh of satellites doing the same thing with a lower cost, and that I can really substitute easily in case there's something going wrong, or even improve it with time. So the time of response is quicker, the expenses could be lower, and there are challenges to solve, but it's quite interesting to see that there are different ways of doing things. There are thousands of different approaches. For example, also for short operations, there is the possibility of using these nanosatellites or small satellites to do activities just for 30 days. And you can launch these satellites even from a military plane that can have this deployed very quickly to provide information in situ. A last thing that I want to talk about in this new space concept is the moon base, or having a moon base. Our Director General is really looking into this topic. And I think, as I was saying, it triggers imagination, it triggers creating something new, looking for really overcoming the current barriers is going to generate technology that, from our perspective, has extremely and clear potential impact on Earth, for also the growing scarce of resources. How do we approach it from the a little bit ESA innovation, and I would say what we're doing from the Technology Transfer Office? We have a spin-out activities, which means from space to non-space. We have a spin-in activities. It's how we can identify something that we are not as good as non-space doing or is doing, so we can make use of this non-space technologies in space applications. So for a spin-out, it's basically where the Technology Transfer Office is working, but we're also trying to moving into this spin-in. We have idea generation, so probably you heard about the Copernicus Master, the Galileo's Master, and other activities are coming. We promote technology and IP from the industry and from ESA, and we accelerate through different programs. You have them here, so feasibility studies, demonstrators is a big. And when I say we facilitate, it's that we are basically putting money to allow the development of these capabilities. Then for spinning, we have other competitions. We also have different networks supporting the typical mechanisms from ESA, TRP, but these are basically funding programs or programs that ESA have to support the research and development in general in space. So the Technology Transfer Office, that's where I'm working at right now. So we have here, you see 5 topics. I'm going to focus the work in which now we have more effort, which is the ESA patent portfolio, the broker network, and the business incubation. We also support investment. We have mechanisms to facilitate access to investment. The venture capital fund, please don't consider at this stage. But there's a 5th thing that is being done that we as ESA or as the Technology Transfer Office, we are not directly involved, but we are cooperating with them. It's a mechanism to support the use of data. And when we talk about data and we talk about technology, for us, they are 2 different things, obviously. A technology is either a software or a hardware, know-how related to this software or hardware. And then data is basically Earth observation data I was talking about, telecommunication data, or even navigation data. So then you can build applications with a smartphone, or you can do something with the product. But in general, they treat or they manage these activities of building projects that solve global challenges with the use of EO data, Earth observation data, positioning data, GNSS, and telecom. So I'll go into detail about at least 2 of these 3 mechanisms I was talking before, the patent portfolio, the brokers, and the PECS. So this is the big network. As of September 2016, we have 16 centers all around Europe. So you can see them in this map. So we have presence Portugal, Spain, France, Italy, Switzerland, Austria, Germany, Czech Republic, Belgium into places, the Netherlands, the United Kingdom, Ireland, Sweden. And we are exploring having these business incubation centers in several other countries. The idea is at some point, if possible, to have a ESA BIC in each of the ESA member states. So as you can see here, we have 130 companies supported by year in these 16 centers, which is probably the biggest network nowadays. And 400 startups have been supported so far. The model of support is the interesting thing. There are 2 main things that are different from other incubation programs. We give 50,000 euros of support, of grants, to the companies that are applying, and this money can be used for prototyping or protection of the intellectual property. And then they have also access to technical support from space industry, universities, or even ESA centers. The idea is also that being part of the network, you gain strength. So we are facilitating more and more the international interaction between the startups that are based, for example, in Germany and move to Portugal, or they are based in Italy and move to Sweden. So that's really happening. On the other side, what we have is a broker network. We call them brokers of technology because they are brokering, they are trying to commercialize the space technology, as are the financial brokers, in a different way, obviously, because the ESA broker network has to be much more specialized in technology. So now we have 15 actually, but it's going to be 16 by the end of the year, because we're also opening one in Hungary. And the idea is that these guys that basically go to the space industry, they identify what are the technologies that they have that have potential for non-space. And then they go to the non-space industry and they talk to them and say, okay, what are your innovation needs? What do you need that we can try to solve with space technology? And obviously then they do the matching. Technologies that they have from the space industry, needs that they have from the non-space industry, that can be automotive, aeronautics, mining, oil and gas, healthcare, so all of them, and we match it. Interestingly, the fact of being part of the network, this is a service that is for free, that the brokers do for free. Interestingly, what we see is that it's extremely good to play in a European level in which you can have these technologies commercialized all around Europe, because you have, for example, the broker in Ireland identifies one technology that have potential in automotive. Obviously, first thing they do is they go to the broker in Germany, and then they say, okay, I have this technology. Can you please open the door in the automotive industry? And then, boom, something happens. Then at least there's a potential initial connection that can be done. So this is one of the startups that we have. This one is based in Bavaria. They are using an electric propulsion that is also used for the spacecraft. And they are basically willing to develop the first personal Hoover to move around with it. An interesting case that I was showing last week to the automotive industry specifically. So this is Hermes. At ESA, we wanted to have a small shuttle that was basically a mission that was cancelled at some point. In the framework of this project, as you can imagine, I don't know if you see my mouse, but you have the heat shields that were basically designed at that point by a German company doing ceramic composites. This heat shield that was manufactured for the nose of the shuttle was then transferred to Brembo, that is producing these, I have to say, high-end brakes that are used in the, I think, the Mercedes S-Class or something like this. But they made a business out of it in the non-space industry. And that's the kind of project that, from a technology transfer office perspective, we are looking at. So just to finish this first part, inspiration, innovation, probably some of you heard about the theory of Elon Musk and other people that we need to be an interplanetary civilization just to, if we look in the longer term, like infinite, at some point we will disappear if we remain in Earth, right? So that's the meaning of moving, and also for the human progress, another planet, and we have to survive in this extremely complex framework. It's highly possible that we will develop technologies that can be super meaningful for the Earth as well, in terms of really making things better than we have been doing it so far. So that's the first part of my presentation. So what I will do, I will put a video to explain exactly what we mean with technology transfer and what we are doing.
À tous les DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top, décollage.
I'm going to show you some of the examples that we have from last year. So I will try to explain them very briefly, but to give you a little bit of an ideas on the kind of work we're doing in the ESA Technology Transfer Network. So this is ESOC. I don't know if you heard about it, but this is the operations center of ESA. I haven't entered in detail about how ESA works, but we have several centers in Europe. ESTEC is the technical center, and it's the biggest facility that we have, but ESOC is the operations center. So there's where we control launch, mission, and other activities, basically. From the mission perspective, what we have is mechanisms to control procedures. Quite a lot of, well, in space, basically, we are very good at having a procedure to control everything, because it's not like any other industry. If you make just one mistake, you can be losing between 5, 6, 700 millions, 1,000 millions, just by making a simple mistake. We take a lot of care about the process and procedures. Thus, the potential use of some of the know-how that we have around this topic is critical, or is critically useful for some other organizations. So last year, we had 2 projects that we're talking, that were related to the aeronautics industry, is how to schedule planning the icing of the plane. So this software that we use for space to plan the missions and the different steps or the different activities that will be done in the mission by a spacecraft has been used for the de-icing process. Each of the steps that has to be followed to avoid having a problem or do not pay attention to certain things, the software has been used in the same way. And as I was saying, exactly the same for the disruptive management system. Then there's another application of complex system behavior modeling tool. This was used by the train companies, by a train company in the UK, sorry, I cannot give the name, to improve their routes in the United Kingdom. Was kind of, Rosat was a old mission that was, as I was talking about Hermes, we have quite several cases that are making use of technology that never flew, that we didn't really have the spacecraft, but we did research and development. So then a transfer happened. So in this case, what we have, what was very important to identify abnormalities of the energy consumption. Well, you know that if the power management for spacecraft are is extremely important. So the same technology is being used now by an energy operator, by an utility company, to look at when something is not going wrong in the network or not going properly okay in the network, so they can do early prediction of potential malfunctioning in the overall grid. Another case that we have from Rosetta, so this was a very specific thing that was developed for the Rosetta mission. It was a pod that has to be extremely reliable and doing the same operation once and another. And this same technology has been used now for the helicopter industry. Well, you know that basically what we had in this Rosetta mission is a miniaturization of the different instruments to do things that are being done on Earth nowadays, but in a small scale, because obviously what we try to do is reduce the weight of the system, the consumption of the energy. So these same people that have been developing this instrument for Rosetta, it's called Ptolemy. So now they are using it for the detection of bedbugs. So this is an interesting case because in the hotels in New York, when they think that they have bedbugs, they have to do a process nowadays that takes like 24 hours. So it means that you have to have 24 hours, different rooms closed, because you have to check the room that is close to it. You have to check several stuff. So the guys came with an idea of using a portable instrument, using the same miniaturization mechanisms that they have in Rosetta to do an identification in 1 hour or 2 hours of potentially bedbugs. So then you don't have to have the rooms closed, which is a lot of money. And finally, basically, they are using a humidity sector in the military UK submarines, because it's important to avoid to have moisture and identify what is the status of the people inside of the submarine. So they need to really take care of the humidity level in the submarine. So the same technology is being used there. Another one, Bepi Colombo. So obviously, this is going to be flying closer to Mercury. So the temperature, the radiation is going to be way much higher. So the same electronics that will be used for Bepi Colombo are now used in nuclear application. It's specifically for fusion technologies. In the F4E is building this reactor that is going to be the first fusion reactor that will be, is an experimental testing, but in a larger scale to have fusion energy. Then we go to the rockets. Manufacturing capabilities we have in space. The same procedure and methodologies have been used again by Airbus helicopters to have a better shape in the tail of the helicopter. So it's basically what they were looking for is that it's more robust and it's easier to manufacture from the experience they have from the Ariane. ISS, obviously we do, as you know, ISS is basically a lab. We do a lot of experiments. So we have several cases here. They basically done this model for the growth, potential growth of, I think it was potatoes in space. So what they learned from the activities that, or from the work they did in the orientation to space, they learned how to improve, I think it was by 65 or 70% areas of the Netherlands, thanks to this model. Obviously, solar concentration devices that come from space, we need to maximize the amount of energy that we generate out of the sun that we are getting. So this technology is being used now by the city of Toulouse. And also ISS lab precision used to accelerate this diagnostic for medical applications. So we have some know-how that come from this device that was working in the ISS called Fuji Rebio to improve the quality of the samples and avoid, they had some mechanical problems. And obviously what we have for space never fails, or we try to avoid that it fails. So they introduced these mechanical capabilities that we had from the experiment lab in the European module in this Fuji-Rebio technology. This is an ExoMars related project. So all of you know what happened with ExoMars. I was saying that luckily we landed on Mars, which was good, but the speed that we had was a little bit, we were speeding too much when we landed. So unfortunately, this technology was not able to be implemented. But the idea is that, you know, that since we have these delays in the communication, so that the rover has certain capabilities to make decisions considering algorithms that it has without the human interaction. So the same technology is being used by the oil and gas industry. We had two technologies being transferred to the non-space industry. There's a high-speed camera that was used for the probability to identify vegetation changes and that you can find online. So the same technology is being used for the early identification of melanoma in the skin or cancer in the skin. There's another use, you know, the cool gas generators are a kind of propulsion systems, small propulsion systems. This same technology is being used now. It's substitute of fire extinguishers for big rooms of servers. So the idea is instead of using water related or that can have humidity or that can humidize or destroy the servers, you have these cool gas generators and they don't destroy the data. And that's it from my side. Technology Transfer Office in the European Space Agency. Happy to share my experience with this Bulgarian project. Thank you for the invitation. We pay a network less a budget of around 0.7 million euros that we give to this network annually to make that that connection between space and non-space needs, or space technologies and non-space needs. So we play this role of public support to make these things happen. See you soon, guys. Enjoy.
Bye-bye.
Bye.